Hey, good morning, everyone. Happy Wednesday. Thanks so much for joining us. We will be having lots of other people continuing to join. So just focus in. Here's what we're asking that you put away the distractions. Dr. Liz is incredibly smart and there's lots that you can learn. So here's how today is going to go. Dr. Liz is going to be presenting. If you have questions or things come up as she's presenting, drop it into the chat, and Allie and I will be gathering those for at the end for Dr. Liz to answer them. So please make sure they end up in the chat. Please know this. There's never a dumb question. There's only your question. And here's what I know. I'm always the question answer on and the question asker. And I often hear like, oh, that's the question I wanted to ask. Thanks so much for asking it. So just know when you ask it, there are probably 20 others on the webinar that have the same question. So be the bold and brave one. So let me just tell you about Dr. Liz. I had the pleasure of being able to be with her in January for a Kel Cairo women's retreat. And EndoAxis was the first sponsor that was asked to be a sponsor, and they immediately said yes. I love this company, and especially loved learning from Dr. Liz. I gotta say, I sat there and I felt like it was like the high fidelity commercial where my brain was just like vibrating, like, oh my gosh, there's so much I don't know. I felt like I was in a biochem class about hormones, because I really had felt like hormones were a linear thing, like A plus B equals C, and it's anything but that. And then Dr. Liz just graciously met with me on Zoom for some health challenges I've been having and just gave me a lot of confidence to lean into the wisdom that I have about my own body. And I so appreciated that. Like, it allowed me to make some really big decisions that I know now on this side of it have forever changed the course of my health in the future. So, Dr. Liz, just to also publicly thank you for that. And so, I'm super excited for her to take the microphone and for all of us to learn. And again, put your questions and your comments in the chat and we'll make sure that we get them answered. So Dr. Liz, take it away.
Thank you so much. That was such a warm and lovely introduction. I need to take you everywhere with me.
It's all true.
Yeah, thank you. Yes, and as Dr. Eaton mentioned, it really is, hormones are so complex, and I love speaking on those nuances. So I'm excited to share today with you, hopefully, good, insightful tips, tricks, tools, and insights when it comes to hormone analysis, specifically as it relates to various women's health concerns. And we'll even go through a little case as it relates to perimenopause. So that'll be a fun end to our conversation today. So let me share my screen. Technology and I, for as much as I use technology, you would think I'd be better with it. It's always clunky. All right. Is everyone able to see the introduction screen? Perfect. Alrighty, so let's dive in. Um, we're going to begin by really talking about the high level insights of what a hormone is. So, as Dr. Barbara Eaton has already introduced, I'm Dr. Liz Bartman. I'm a naturopathic doctor. I do serve as chief medical officer for a company called EndoAxis, where I focus predominantly on really trying to reshape and redefine what it is to think about sex hormones, stress hormones, and everything in between. Our company is focused primarily on developing herbal supplements and bringing back the wisdom of our herbs as they relate to hormone balance, as well as nutraceuticals blended in a way that targets what I like to call the why and not the what of hormone imbalance, meaning why are the symptoms present? Why is the hormone functioning or behaving the way it is? Not just what is the symptom, but what's driving that. And I'm going to show you a little under the hood of what I mean by all of that. So today we're going to talk about the complexities of those steroid hormones, advantages and disadvantages and ways to test, as well as how you can gain those deeper insights and come out of this as a hormone expert today, or a little bit more. So to do so, we really want to pull out, and I want to take an opportunity to look at all the things that are influencing our hormones, not just the hormone itself. So instead of just looking at the Earth as a planet, let's really zoom out and say, okay, what are all the factors that result in that hormone story being as unique as it is for every bio individual on this planet? To understand, we're going to dive into the story of a steroid. So a steroid hormone, all of our sex hormones are steroid hormones. meaning they are cholesterol based. Very few hormones in the human body are cholesterol based. So they are very unique in that way. This means that a few things are true about steroid hormones that I want everyone to understand right from the get-go. Number one, there are only a few target cells in the body that can actually make sex hormones and cortisol and DHEA. Um, these are cells in the human body that are capable of transcribing a gene called STAR, which is steroid acute regulatory protein. To be really specific, there's actually only 3 cells that can do this. And we'll talk about those 3 here in just a minute. Synthesis begins in the mitochondria, and it's the mitochondria that contain that steroid acute regulatory protein. So only cells that have the mitochondria that have the transcription of that gene can make a steroid hormone. Because they're a fat base, remember all of our cells are phospholipid bilayers. So as a fat, if a hormone is free, it can passively diffuse into those cells. Once the hormone is within the cell in that cytoplasm, it has a few things that it can do. It can either be transformed into intermediates that have other function within the body, and that's through the endoplasmic reticulum, these little factories that are taking that cholesterol and just augmenting it a little bit. Or if that cell has a hormone receptor, that hormone can bind to it. So for the hormone to really be potent and active, it has to have its receptor buddy. They bind, they form a hormone receptor complex. That's what goes into the nucleus of the cell and can actually augment DNA transcription and behavior of the cell. So very interesting, very potent. They're very expensive to make. They require a lot of resources. Again, they need mitochondrial function, they need energy, they need cofactors. And in the same vein, they are very expensive to break down. They require a lot of resources and cofactors for the body to process and remove and make those fats into more and more water-soluble intermediates for final elimination. So just to point out, those 3 cells that can make steroid hormones specifically are sex hormones. In the male tissues, it's really just in the testicle, and it's specifically the Leydig cell that can initiate hormone synthesis. In the ovaries, it's just the thecal cells. The theca are the layer of cells around each of our follicles, the granulosal cells. And those are the cells that don't get talked about a whole lot, but are really the ones that initiate hormone synthesis. And then in the adrenals, the adrenal cortex. So I did want to point out, this is a great website. This is proteinatlas.org. What this website does, it's a worldwide database of collection of research that's looking at not just the genes. I should circle back. My background's in nutrigenomics and genetics. I love diving into the genes. And so when I look for function and when I'm looking at genetic expression, I'm thinking, oh, okay, this is what this enzyme does, and this is its activity. These are its cofactors. I also want to know, well, what tissues can express it? You can go to proteinatlas.org. You can type in any gene you want into the search field, and it will pop up the tissues that express that gene. It's really fascinating. And that can give you further insight into saying, oh, okay, if this is the tissue that's expressing that gene, then that's where, for example, hormone initiation begins, right? For our steroid hormones, specifically our sex and some of our stress hormones that are steroid based. So very interesting. And you'll see me reference this database a few more times in this lecture, but to give you that insight, if you like to nerd out like I do, you can go in here and type in any gene and have fun with it. But let's now go in to the solar system a little bit more. So we were out in the galaxies, we're really getting that big full picture. But let's start to look at, well, okay, knowing what's involved and where these proteins exist, how do hormones produce? How do they circulate? How do they transform and function in the body? How are they then broken down and conjugated, and how are they eliminated? And each step along the way, what does that tell us about function and about behavior and even about conditions that might be exacerbated because of dysfunction within one of these steps? So I'm going to start with production. Remember, for production to begin, we have to have cholesterol. We have to have cofactors, specifically magnesium, zinc, vitamin B6, and iron. Anytime you see a CYP enzyme, just know that iron is the igniter for that enzymatic response. So we don't want to be iron deficient if we're working on fertility, for an example, or if we're working on hormone optimization. We need to make sure our iron is in a good place, but not too high because we can also oxidize iron, so it becomes a balancing act. And then we need optimal mitochondrial activity. Remember, our gametes and the cells within our ovaries and the testicles have some of the highest concentration of mitochondria of any cell in the body. because they are generating our steroid hormones, our sex hormones. But we need to make sure that they're optimal, that they're functioning well. And one of the things that initiates and supports that hormone synthesis is vitamin A. So I put some of the things vitamin A is known for, but more importantly, remember that steroid acute regulatory protein? I keep harping on it. But that is the initiator of steroid hormone synthesis because within the mitochondria, it gets activated by luteinizing hormone. It is told, okay, let's pull in cholesterol from the bloodstream. Let's start to transport it into the mitochondria where it can become the master hormone pregnenolone. For STAR to work, A, we have to have mitochondria healthy and optimal, but B, we have to have vitamin A. So the transcription to make STAR into a protein in the body has a retinoic acid receptor complex at the promoter region of the gene. If you do not have vitamin A in the retinol form, you do not turn on transcription of STAR. So we need vitamin A. It's critical when we're thinking about infertility, hypogonadism, hormone imbalances like PCOS or endometriosis, even our perimenopausal journey and trying to like balance hormone response and optimize function as best we can with our last remaining granulosal cells. Vitamin A is a key critical cofactor. Now, in the retinol form, vitamin A in the natural world, in the plant-based world, comes from beta carotene primarily. If you have a patient that has malabsorption issues, IBD, celiac, Crohn's, if you have a patient that doesn't eat a lot of fats, doesn't eat a lot of meat, you're going to have patients that maybe are low in vitamin A and are going to start to see that decline in their sex hormone activity and balance. So I just like to throw that one out there, especially for our vegan and vegetarian patients. Make sure that they have a good retinol form if we're trying to if they have issues with hormone production and we're trying to optimize hormones. So I'll throw little nuggets like that along the way. The story of the hormones then comes to the production. So now we know all about STAR, we know about the cofactors required. Well, what happens when we actually start to synthesize the hormones? I do have both the testicle and the ovary shown on the screen here, but we're talking about women's health primarily today. So just focus on the ovaries. But what happens to initiate the sex hormone cascade is it's not like we just turn a faucet on and make a ton of estrogen or turn a faucet on and make a ton of testosterone. No, they all are built from a series of steps that start with pregnenolone. So, how does that start? Well, it starts by having that sudden loss of estrogen and progesterone at the end of the menstrual cycle, releasing the brakes on GnRH, gonadotropin releasing hormone, which is in the hypothalamus. It then communicates to the brain and says, hey, we're ready to start a new cycle. Let's go. Well, the brain also has to say, okay, yes, we are in a safe space. We are in a space that's ready to try to develop, release an egg, and conceive again, right? And so the nervous system is all along regulating this process as well. I do throw in the adrenals because we think about, cortisol being a master stress hormone, and it does sustain our stress response, but the initial trigger for stress comes from norepinephrine. So that's really the critical peptide hormone response within the adrenals that says we're stressed and triggers ACTH. And the reason I want to talk about them together is that if we're getting a ton of response to the hypothalamus that says we're stressed, we're going to downregulate GnRH and push preference towards CRH, corticotropin releasing hormone, to release ACTH to knock on the adrenals and sustain our stress response at the expense, sometimes with chronic stress, at the expense of our sex hormone synthesis. So we see this in chronic stress situations, be it hypothalamic amenorrhea, be it thyroid imbalance as well, where we're really trying to push emphasis on the cortisol on the adrenal side at the expense of then signaling to our ovaries that we can start developing an egg and generating our sex hormones. So another thing to consider as you're evaluating your patients. Are they in a stress response or are they in a relaxed state and are ready to regenerate their sex hormones for another cycle? Now, once LH is released, LH knocks on the door of the mitochondria of those theca cells. And remember, the theca cells are the outer layer around each of our follicles. Inner layer is the granulosal cells. When LH hits and knocks on that door, it's activating STAR, which I just put as a little star icon, easy. And that's going to trigger a series of other enzymes to express within the mitochondria, as well as within the granulosal cells. So cholesterol comes in. We're starting to pull in our building blocks, CYP11A1, so CYP, iron dependent, is coming up in regulation to convert that pregnenolone or cholesterol to pregnenolone. 3-beta HSD converts into progesterone, and then we can pull it into the endoplasmic reticulum outside of mitochondria, right in the cytoplasm, to further convert into androstenedione, testosterone, DHEA, all of which, again, because they're fats, can passively diffuse into those granulosal cells that are growing this entire time within the mature predominant follicle for the month to convert rapidly into estrogen. So this is the process of hormone synthesis that's happening every cycle in a female body. And I think it's so amazing and so complex. Now, if we start to think about conditions where things might go awry, well, CYP19A1 is the enzyme aromatase that's taking those androgen intermediates that are being made first through the hormone cascade. If CYP19A1 isn't functioning optimally or isn't getting expressed, either because of polymorphisms or environment, blood sugar dysregulation can be another one, you may start to see a backlog of androgens and less estrogen response. This is a classic presentation for PCOS, where we then want to start targeting CYP19A1 as best we can to promote that granulosal cell development. Remember, as LH and STAR go up, the other thing that's activated is more and more FSH receptor response to grow and develop that egg. If you're seeing high LH and low FSH, that's a classic PCOS presentation. We're getting this loud knock on the ovarian door saying, come on, let's start developing a new follicle. But because you can't aromatize and you're not increasing the concentration of FSH receptors, you're not getting that development of one dominant follicle for the month. Instead, you're getting lots of little underdeveloped follicles, which is kind of that classic string of pearls presentation that you can see on ultrasound. Um, and that's really this kind of dysfunction at the core of that androgen dominance. It's not always the case. You can have androgen dominance with appropriate aromatization, but that's not what we would call like a classic PCOS presentation. Those can be driven by other factors like inflammation. IL-6 and TNF-alpha are big ones. I do put a little blood vessel here, but remember, there's also tons of blood vessels running through our ovaries, as well as lots of lymphatic tissue. And our sex hormones can be picked up and delivered outside of the ovary as well through these channels. But to do so, because they're a fat, they have to be loaded onto a bus, a protein, because our blood is mostly protein and water. And what happens when you pour olive oil into a cup of water? It floats to the top. They do not mix well. So fats need to be bound to a protein in order to circulate outside of these reproductive tissues. But they do have other roles in the body, right? We know estrogen plays a big role in a number of transcriptional pathways in our brain for acetylcholine response, for tryptophan conversion to serotonin. It plays a role in nitric oxide response in our endothelial tissue. It plays a role in the liver for fatty acid metabolism and choline synthesis. Of course, it's a big player for bone turnover. We need to get it to other tissues in the body. Our sex hormones, because they are so potent, also have lots of interfering factors, not only from our genetics, but also from our immune regulation, our stress, our gut health, what our gut is doing with our hormones, or the inflammation and regulation of nutrients and cofactors from the gut influencing hormonal activity. So not only are there hormones impacting us and our genetic expression in various tissues, conversely, our environment and everything around us, including our gut and our nutrition, are impacting our steroid hormones. So it's this beautiful, complex web of information that all has to be received. And if you're only looking at hormones in isolated silos, if you're only saying, well, this is what estrogen is, this is what testosterone is, and you're not looking at the metabolites and you're not looking at those intermediates, you're missing a lot of this story that could actually be the underlying driver of a lot of the symptoms that the patient is experiencing. So what can these steroid hormones tell us? Let's talk about that circulation. So remember, to get out into the circulation, they have to be loaded on a bus. SHBG, sex hormone binding globulin, is the primary bus for our estradiol and our testosterone. We can sulfate estrone and DHEA. That's how they can circulate through the bloodstream. And progesterone and cortisol actually bind to the same binding protein called cortisol binding globulin. Interesting. Now, once they are circulated, they're bound. If they're on a bus, they can't get into the cell. And remember, it's the cell that has the receptor that can then augment cell behavior. So we need it to be in free form to be able to passively diffuse into those tissues, to bind to those receptors, and to have cell activity. That said, hormones, especially estrogen, can also act non-genomically on the cell receptors in a few target cells, specifically the endothelial cells. So we have predominant genomic effect from estrogen, from testosterone, and even from progesterone a little bit. But we also have that non-genomic effect. And I want to talk about vasodilation and heart health here, because all of this is going to lead us to our perimenopausal journey here in just a moment. There's a method to my madness of why I'm giving you all this information. But the non-genomic aspect of E2 is that it acts on these calcium channel vaulted gates within the endothelial tissue to create an immediate vasodilation. Estrogen can also go into the endothelial cells of our vascular tissue and increase nitric oxide synthase. So we're increasing nitric oxygen. Nitric oxygen or nitric oxide is a potent vasodilator. It's allowing the estrogen also allows for elasticity and that collagen response of our blood vessels. So it's allowing for smooth response both to the stress of our heart, like it lowers our blood pressure, it lowers our pulse rate, it keeps us autonomically balanced. When we're stressed, our heart rate goes up. Estrogen helps to kind of relax that, to keep our nervous system toned, our vascular tissue toned. Nitric oxide is also a free radical scavenger, so it is an antioxidant. What happens when estrogens start to decline or become erratic? We lose some of that benefit, right? In our cognitive function, estradiol goes into our neurons and it can actually increase tryptophan conversion into serotonin. It increases BDNF, which is acetylcholine response in the brain. It's these little spinies, these are dendritic spines. It increases the dendritic spine proliferation within the neurons, which allows for neuroplasticity in the brain. So it does a lot for us. And I'm harping on estrogen right now. Progesterone helps as well. Progesterone is an aid for GABAergic influx into the neurons to help with GABA flow. So it calms the nervous system. Testosterone supports dopamine response, supports bone turnover. Progesterone actually protects the bone as well. So all of our hormones are playing a role outside of just reproduction. I liked this graphic. This actually is our postmenopausal female struggling with obesity, right? Like weight gain can happen during menopause or during that perimenopausal transition because we're losing our source, our ovarian source of estrogen. And so our body is wise. It's saying, well, our adipose can kind of give us a backup here. We're going to start redistributing our adipose a little bit so that we can have a little bit of a reserve once our ovaries can no longer contribute to our estrogen output ongoing. So the body is doing what it knows to do, but if we have other inflammatory and metabolic factors driving that activity that's already naturally happening, if it drives it even worse, then we start having uncontrolled weight gain and we can't lose the weight and we get, metabolic syndrome. It can become quickly a cascade of symptoms we do not want to experience that would have a detriment to our health span, right? We're all about optimizing health span. So other things estrogen does, in addition to it's supporting our blood sugar balance through peroxisomes, it's balancing leptin response. So that feeling of being full and then like burning fat from our adipose, it helps to regulate that. Of course, again, our immune modulation, it helps modulate and reduce TNF alpha and IL-6. So lots of things that give us a little bit of that protection that when we start to lose that or it starts to go awry for any reason, I guess, how do I want to phrase this best? I have like this mound of stuff I want to just say and get out. I'm so excited. I always get so, psyched about this conversation, but I think really what I want to bring home is that our sex hormones really give us a big buffer and provide so much support in our bodies that be it high stress in a young cycling female that's lowering hormone optimization, or be it perimenopause, or be it that late peri and into early postmenopausal transition, when hormones are really starting to radically change, we lose that buffer. And any metabolic imbalance that was present already underlying that surface layer or under that protective buffer of our hormones is revealed. It's unmasked. And so in understanding the role that these hormones play in our body and all the buffers and protection they give us, you can start to piece together when symptoms start to arise, which hormone may be the culprit and where we may want to support outside of even just the hormone itself. Because often what we find, and you probably have experienced this if you do bioidentical hormone replacement as an example, once that mask has been removed, and the metabolic responses have been revealed that are out of balance, that have always been brewing a little bit, those little undercurrents, bringing hormone back doesn't, like, we can't sweep it back under the rug. It's been revealed. Bringing the hormone back can keep us in a better state moving forward. But we still have to address those metabolic concerns for optimal hormone balance and to feel better in our bodies. So that brings me to then how do we metabolize our hormones? Because on the flip side, if we have a lot of excess hormone, that doesn't help us feel good either. Too much estrogen can make us feel very bloated, can make us feel very inflamed, can cause tissues. Estrogen is a grower. So estrogen receptor sensitive tissues become more proliferative, like our breast, like our endometrial tissue. We have more painful periods. So as we're breaking down our hormones, I like this graphic. I like to, the biochemical response to show why estrogen metabolites are called what they're called. So this is our estrogen, right? Our estrone. And when it's metabolized by CYP1A1. We call this colloquially, they call them the good, the bad, and the ugly. So I think of it more so as the preferred, the equivocal, and the proliferator. But we have the CYP1A1. This is going to add a hydroxyl group to the two carbon base of the benzyl ring of the estrogen molecule. It's making it a little more water soluble. It's very stable. And so the reason this is called the good, or I think of it as a preferred, is that as long as it's stable, it can be, and as long as we have a lot of methyl groups available, it can go through methyl detox and eliminate through the body pretty quickly. The 4-hydroxy is a hydroxyl group at the fourth carbon ring. This is called the ugly. 4-hydroxy on its own, though, is not the problem. It's when it transforms to a 3,4 estrone quinone. The quinones go and damage DNA. They create unstable adducts that can render cell replication ineffective over time, that can lead to those aberrant cell changes that lead to cancer risk. So yes, we want to monitor 4-hydroxy very closely, but 4-hydroxy on its own is not the bad guy. We also want to take into account how is their pyroglutamate for glutathione conjugation and removal? How is their methylation? How are we binding and conjugating this to the methoxy form that is very inert? These are both called catechol estrogens because of the location of their hydroxyl groups on the carbon chain of the molecule of estrogen. 16-hydroxy, this is called the bad, it's the proliferator, but you can see it's on the 16th carbon. It's way removed from that benzyl ring. It's not a methyl dependent intermediate. So the catechol estrogens are 2 and 4. These are catecholamine, they're dependent on catecholamine O-methyltransferase, COMT. But don't look at just methylation to determine if your patient is a good detoxifier. You also have to look at their 16-hydroxy because this is derived from CYP3A4, which is predominant in the liver, and it is dependent on sulfation for elimination. So it goes through a completely different pathway. And I always like to point that guy out too. But when I think about detox, I think about estrogen kind of being swept into little piles. These are the little piles. Each pile has its different function. So, CYP1A1, the 2-hydroxy pile is basically like your general refuse. You can, oh, sorry, CYP1A1 is like your recycling pile. Let me get my brain all straight here. I apologize. I have been getting over a cold, so I feel like I'm a little discombobulated. But CYP1A1, just like your recycling cardboard, you can build up your piles pretty quick or pretty large piles in your home without much issue, right? You're not going to be a health hazard. What can happen though over time is it can become a tripping hazard. It can be a problem. We need to get it out. It's just not going to be an overt problem right away. The CYP3A4 is like your general refuse. This is like your garbage. You want to take it out at least once a day because otherwise it can start to smell and gather flies. And then the 4-hydroxy is more like your pile for like your compost. You don't want food waste sitting on your counter for more than really a few hours at a time without taking it out to your compost. Otherwise, it can really get moldy and stinky and gross, right? So that's kind of like those are our little piles. But then they also need to go into garbage bags. And those garbage bags are, again, the methoxy bags for the catechols or the sulfation bags. And then they have to be taken to the dump quite literally, which means they have to be excreted out of the bowels. Now, what I wanted to point out, and this was supposed to be a screen that was Oh, this is a bummer. The screen was supposed to actually be in three parts. I don't know if it's going to work for me. Well, that's a bummer, bummer. So what I wanted to point out was the Human Protein Atlas, and specifically where in the body the enzymes are expressed, because we always think about estrogen detox as being in the liver, and it's not. CYP3A4 is in the liver. That is our predominant. So when you're seeing, and it's also the dominant when our estrobolome is reconjugating estrogen, it hits back into the liver. So when we're seeing high 16-hydroxy-E1, it can be a sign that we're recirculating estrogen because of high estrobolome or gut issues, and or that our liver is taking the bulk of clearance of our estrogens. But the 2-hydroxy and the 4-hydroxy are considered extrahepatic enzymes. And I will show you this at the end of the slide deck. I'll go to the website and show you because I think it's really important to know that these enzymes are not made heavily in the liver. They're actually made more so they're expressed more in the kidneys, in the lungs, in the endometrial tissue, in the breast tissue, in the ovaries. So it's not, so for example, with 4-hydroxy, it's not that it's a bad estrogen because the liver makes a ton of it and circulates it to the breast. It's because it can express in the breast. And if it doesn't get methylated right away, it can start to damage the DNA in that local tissue. That's why we want to monitor it. That's why we want to help eliminate it if it gets too high, and why we want to support all the routes of conjugation we can, which include, again, optimizing methylation, but also glutathione conjugation and clearance. The other thing to know about these enzymes is that specifically with 4-hydroxy, so we talked about 16. If you have gut inflammation or high estrobolome response, you're going to recirculate your estrogens heavily into that 16-hydroxy pathway. So think gut when you see 16-OHE1 elevated on a test. With 4-hydroxy, it's heavily expressed in the lungs. CYP1B1 as an enzyme upregulates in transcription specifically because of environmental stressors. Its primary conjugation is not estrogens, it's polyaromatic hydrocarbons and benzyls and benzyl peroxides and benzenes. So it's chemicals. So if you're exposed to a lot of smoke, a lot of anything lit on fire and inhaled into your body, or even smoked or charbroiled meat products, this can upregulate transcription of that enzyme and increase your activity of estrogen conjugation into these not ideal pathways. So think environmental exposures when you see 4-hydroxy elevated and support the environment. So again, we think detox, abnormal detox influenced by polyaromatic hydrocarbons, the impact of caffeine. Coffee will actually increase CYP1A1, but it suppresses methylation. We don't want that. We don't want to push a lot of piles without the garbage bags being ready and available. So think about coffee as a potential player in why women might experience high hormone imbalance or estrogen dominant symptoms. Glyphosate exposures, even mold and heavy metal risk, can definitely play a role in depleting our methyl groups, can play a role in how we transport and circulate our hormones, and even how we ultimately get rid of our hormones. Our immune regulation, right? We can start to see how is our immune system playing a role? Is stress a big part of our picture? High cortisol can actually increase CYP3A4 as well, pushing 16-hydroxy. So if you're under a high amount of stress, maybe you're not pooping every day and you also have high estrobolome activity, you may experience more estrogen dominant symptoms, including those painful menstrual periods, heavy menstrual cramping, fibrocystic breast changes. You may experience more menstrual related migraines or tension headaches. I see, sometimes like even mast cell activation can be a problem because too high estrogen can cause DAO, diamine oxidase, to not transcribe as readily because we need a little histamine for implantation and fertility success. But too much estrogen out of control. Now we're starting to get histamine response as well. So lots of like symptoms can be connected back to the hormones and how they're being processed and utilized by the body. So then we have to talk about that elimination. And remember that final elimination is the conjugation, the taking of the hormones. Now they're in their trash bags. Now we have to take them to the dump, quite literally. And this is where our estrobolome comes into play. So there's a group of commensal bacteria in the gut that create an enzyme called beta-glucuronidase. And this enzyme can cut through that side chain, that glucuronide side chain that's conjugated those garbage bags, right? That's conjugated the estrogen. So I think about this as like the string tying all the garbage bags together. And I think about beta glucuronidase as the little rats that can go and chew through those strings and release the estrogen back into circulation. And when that estrogen goes back into circulation from the gut, it goes through what's called the enterohepatic vein. And that hits right back into the liver. And what's the enzyme most highly expressed in the liver? CYP3A4. So again, that's why we focus on gut health, biliary health, bioconjugation, and making sure that our patients are pooping every day. Because if you're not eliminating that final end product, you're going to have an estrogen imbalance. Now, I want to throw out two things about the gut in this phase. Number one, when you're in your peri and really your like late peri and into your postmenopausal transition, you don't have as much estrogen any longer. And so having higher estrobolome response and recirculating your estrogens can actually be of benefit. So it's not that the estrobolome is all bad. It's just if you're a young cycling female and you already make a ton of estrogen and then you're recycling it and hitting on those receptors over and over, now we're creating insult to injury, right? Like now it's becoming a problem. So it really depends on the life stage of the patient as well, whether or not we want to aggressively address beta glucuronidase and the estrobolome and gut health, because sometimes they can be to our benefit. Another aside that I wanted to put here, just as a little clinical nugget, if you're seeing really strong beta preference, we always think about 5-alpha reductase and 5-beta reductase. I was taught this anyway, as like two parts of the same enzymatic chain. And they're really not. They're completely different enzymatic families. So 5-alpha reductase is your SRD5A family of enzymes. Your beta reductase enzymes are aldo-keto reductase enzymes. And these enzymes are heavily expressed mainly in the liver and the gallbladder and the small intestine. So when you're seeing beta metabolites, it's often a sign, and I should say the alpha receptors are often in skeletal muscle tissue, the prostate, endometrium. They're like in active tissues that need that hormone in its active form. If you're seeing a lot of beta clearance of sex hormones, especially in like urinary testing, it can be a sign that their bile pool is low. So our sex hormones, because they are cholesterol based, what is bile made of? It's made of cholesterol. If we don't have enough biliary conjugation like backbone, we can actually take our sex hormones and add to our biliary pool for digestive support. We've found that people who are pushing more beta can often, this is seen in patients that have like early fatty liver disease changes. It's seen in metabolic syndrome changes. So that higher demand by the body for optimal biliary health can shunt your hormones more into the beta path, which means they're not getting utilized at the receptor response at some of our key target tissues as robustly, which can reduce, like in the for androgens as an example, can reduce their androgenic potential. But remember, progesterone is also subject to 5-alpha and beta reductase. And beta metabolites of progesterone, it's very active in the endometrial response as well, but not going to convert to that allopregnenolone intermediate that we think about for the GABAergic response associated with progesterone. So for people who are like taking progesterone orally and they're not pushing into the alpha pathway as much, maybe their beta is really high, and they are like, I'm not getting any sleep benefit. It's because of the way they're metabolizing. Support their liver, right? Support their nervous system. So this brings me to how to test hormones, because I'm talking a lot about metabolites. And unfortunately, you can only see metabolites if you look at urinary clearance of hormones. And again, when we think about hormones, we often silo them and we think of absolute values. And so serum becomes the way that we often assess. But I'm going to tell you why that may be misleading in some cases. Not to do it, like it's still a very important way to assess hormones, but you need to do it correctly. So we can test our serum. Remember, it's going to be mostly protein bound, but it's showing us what's in circulation. That's important. What's actually getting out to our tissues for those other physiologic impacts. You can look at salivary testing. This is optimal for cortisol, and especially when you're looking for those changes over time for our diurnal pattern, what's called the cortisol awakening response. And then with urine, you're looking at an end product. It's excretion. But in that metabolite excretion, you can reverse engineer and say, oh, these are the different pathways. And now, I know I threw a lot at you already, but you can go back onto the slides and say, oh, Dr. Bartman had mentioned if CYP1B1 is upregulated, think environment, think polyaromatic hydrocarbons. I'm seeing high 4-hydroxy. I'm going to assess that for my patient, right? So you can start to reverse engineer and say, okay, what other things do I need to consider outside of just the absolute value of the hormone itself? So the value in each, as the brain is sending that communication to the little ovarian factories and they're generating all their hormone, serum is showing what got loaded on the bus, right? It's really what's on the van and available for transport. Saliva is the free fraction. It's what was left at the doorstep, but we don't know if it's getting used. We don't know if it was taken in, if it saw a receptor or not. Urine is basically the bioavailable fraction, meaning to be a urinary hormone metabolite, the cell receptor and the hormone receptor had to have seen that pass through. Now, did it use it or not? We don't know for sure, but it did pass through in bioavailable form. And more importantly, we can see how it was unboxed and ultimately thrown away and discarded. That gives us the impact that could be influencing the hormone behavior and symptoms. The other advantage to urine, so serum and saliva are a single point in time, and hormones are very variable. And I will show you how bouncy they really can be throughout the day. Whereas urine is getting a capture of a roughly 24-hour window of time. So you're capturing all the peaks and troughs that occur throughout the day and all that end product accumulated to see a total daily average versus a single point in time. The reason a single point in time can be misleading is because hormones are very pulsatile. Again, it's not like you just turn a faucet on and create a hormone and it's there all day long for you to access. They vary. They vary based on stress, based on diurnal pattern, based on sleep, based on protein binding. But progesterone is the most, what they call bouncy of all the sex hormones. Progesterone can vary 80% in just 90 minutes. And it was actually from this study that the researchers said, really, to get an accurate progesterone, you should be testing women 4 times on their mid-luteal sample, day 21, or roughly 5 to 9 days before their next menstrual period. Otherwise, you could test a patient at 8 a.m. and again at 9:30 and have an 80% different value. What do you do with that information? So generally, hormones do peak in the morning. The ultimate consensus was no one's going to go into the lab and get poked 4 times. So just try to make sure it's a morning sample and you're probably going to get their optimal output. Okay, that was what they agreed upon. That works. Again, timing of the cycle is important as well because we only make progesterone after we release a follicle, right? So we have all that granulosal cell response generating tons of estrogen for us throughout the month, but then it's not until that we rupture the follicle, release the egg, that we caveate back, and all that mitochondrial rich tissue starts to generate progesterone for us. That's what they call the luteal or mid-luteal peak that we're aiming to collect to know what is our output. Did we ovulate? What is our endometrial response? Are we fertile? For testosterone, most of the studies are done on men. This is a disservice because I think, testosterone is very important for women as well. We are starting to get more studies, but they are slow to come into the mainstay. But what we know from men and their dominant hormone is that androgens tend to peak in the morning as well. They actually tend to rise around 4 a.m. with maximal output around 8 to 9, and then they start their decline around 10 to 11 a.m. So if you're testing male patients, you always want to tell them to do a morning sample because if they're collecting in the afternoon, those averages, we don't know what to do with that information. They could be low, but it's just because they're in a downward peak naturally, and that's where they're supposed to be. So really making sure you're collecting at the right time of day. And for androgens, you want to collect on 2 non-sequential days because androgens do change a lot as well. And stress level and sex hormone binding globulin response and liver health and diet can all play a role. And then estrogens do have more of a steady state throughout the day, but again, they do tend to peak most in the morning. And they're going to have the most variability in the follicular phase. There's really no rhyme or reason to what's happening. And then you want to test it in the luteal phase to complement progesterone and know what's happening with that endometrial protection. Remember, estrogen is the building blocks, kind of like the bricks that are lining the endometrial wall. Progesterone's the mortar that holds it all together. So if you have patients that are having mid-cycle spotting or are having really heavy periods, especially on day 1, they may be lacking that mortar. They need more progesterone, right? Versus patients that maybe have really, really prolonged cycles, they may not be getting that maturation to the egg or of the egg to reach that rupture. It's taking them a lot longer. So in that case, they may need more follicular response, more estrogen response. So again, just a few little things to think about as you're thinking about this process through. Again, urine is giving us that daily average. So we're really seeing the peaks and troughs. I just wanted to give you that visual to reflect that aspect of collection as well. And again, we were talking about the cycle changes because when to collect each of these hormones is really important to assess as well. When you're looking at peptide hormones and signals, you want to do it at a baseline when everything should be nice and low, right before the next follicle is about to mature. So that's really going to be that day 3 or roughly day 2 to 5. That's going to be your LH and your FSH. AMH, if you're looking at that as well, or prolactin, better to test here as well in that kind of early follicular. Whereas the luteal, we don't even make progesterone, right? This is the progesterone line. We don't make progesterone until that luteal phase after ovulation. So really wanting to capture that day 21, that peak progesterone day. And again, this is going to change for every woman. This is day 21 of a 28-day cycle. So again, I always say just count back 5 to 9 days before your next expected period to see that peak rise. But all of this to say, what happens in perimenopause? Because during our cycling lifespan for a woman, we are getting these nice rises and dips throughout the month. We're always changing, but we have some consistency to that change, right? In perimenopause, this green line is estrogen. It is going all over the place because those last remaining follicles are struggling to reach maturation. The greater the oxidative stress or inflammation, the greater this dysfunction can become as well. Progesterone is basically on a downward spiral, right? It's just heading on down because we're not ovulating with the same regularity. And FSH is trending often kind of irregular, and then by kind of mid-late perimenopause, it's starting to trend upward, right? So things are starting to shift and things are not as clear. Not that they were really that clear to begin with, but now a single point in time is even more variable. Even with urine, it's only a single day in time. We could miss quite a bit if we're not collecting multiple days throughout the month. So what do we do? Like, not everyone's going to do this. Not everyone's going to test this frequently, nor should they. In fact, the diagnosis of perimenopause, let's start talking about what happens when hormones start to fluctuate erratically. Diagnosis for perimenopause is not based on lab testing at all. It's based on symptoms. So do they fit age? Do they have a change to their cycle length and flow? And do they have the vasomotor symptoms that are consistent with perimenopausal change? So hot flashes, night sweats, the vaginal changes, the insomnia, the mood changes can also correlate. There's actually a whole list of odd, bizarre symptoms that are correlated with this estrogen alteration and decline in progesterone. And of course, ruling out any other pre-existing health conditions that could be causing those symptoms to occur as well. So saying, okay, they're not hypothyroid. They are, 48-year-old female. They have hot flashes and their cycles are starting to become really irregular. Yep, diagnosis of perimenopause made, right? And more importantly, what came of a conversation recently, this came out of the British Medical Journal in 2025. And they said, could menopause misinformation be harming care for our patients? And their argument, there we go. Sorry, my slides are a little funky. What they basically pulled was that we are testing possibly too much in our cycling females. And we could be missing, because we're testing maybe not in precise ways, we are missing the key signs that would suggest that in their case, bringing in BHRT, or in our case, you could do BHRT or you could complement with herbs, could be missed because they could be collecting a day and say, well, estrogen looks fine. So yeah, they're having hot flashes, but we don't need to add estrogen yet. And that could actually be harming care because we know that initiating hormones, if that's like, a desire for the patient, initiating hormones earlier can help mitigate a lot of those symptoms that come as those hormones start to decline into our postmenopausal years. So we have better bone protection the earlier we start initiating estrogen as it's going into its decline. As an example, we have better sleep management if we can initiate hormones a little earlier. And they actually said from this that for midlife women, effective treatment begins not with numbers, but by listening. And I thought that was really profound because they're emphasizing the fact that symptoms really do suggest deeper imbalance for the patient beyond the numbers on a report because hormones are so variable and they do change so much. And could we, by looking at a single day in time, be missing key information? Now, I would say if you're looking at urine and you understand that metabolic journey, regardless of what the absolute hormones are telling us, if we're seeing dysfunction with how they're processing, how they're pushing their androgens, how they're pushing their cortisol, how they're metabolizing their estrogens and their progesterone, that can give us a lot of great information on where to target treatment and support. So I would say, yes, symptoms are very important, but if you can overlap it by understanding also that metabolic imbalance, we're going to give our patients like stellar care, right? Now, to test or not to test? Well, absolutely. Serum testing is critical if you're looking to diagnose. And you just have to test it the correct way in the morning at the right time during the cycle. Urinary testing is that metabolic insight. And when you're looking at perimenopause, there are some key markers that I would suggest you do measure, right? It's not saying don't test. In fact, FSH is a great marker to track. And it will be all erratic in perimenopause. So it's not telling us necessarily that they're like this is your X amount of time before menopause, but it can tell you a lot about metabolic dysfunction, cell signaling, oxidative burden, and follicular kind of response and decline. So it is a good one to track. And FSH goes beyond just maturing a follicle. We're actually seeing FSH as it relates to adipose tissue. It stimulates aromatase in adipose. So the higher FSH starts to climb in perimenopause, the more dysfunction we can see with leptin resistance, insulin resistance, and adipose proliferation. It also increases bone turnover. So we want to track it. We want to monitor it. But more importantly, outside of the hormones, in our perimenopausal years, we want to look at our lipid panels, our inflammation markers, our thyroid balance, and our blood sugars. Because remember, it's the metabolic imbalance that's brewing that's been supported by our estrogens being in a good place, or our hormones being in a good place for so long, that once that mask is removed, we start to get significant symptom activity. This is where those symptoms are driven, and this is where we want to treat and support. So this is what we want to assess in our perimenopausal women. And then looking at cortisol, looking at their diurnal response, their cortisol metabolism, looking at those metabolomics of hormone clearance and what is the story that it is revealing, and even looking at the stool health for a strobilome response. Like, do we need to support it for a little while estrogens are erratic, and then maybe let it ride at the higher level into postmenopausal years to support estrogen potentially? So that brings me to what is EndoAxis, because this is a lot of information. And hopefully you can see that I'm passionate about it. I get excited about it. And the information that we've aligned within the EndoAxis platform is that metabolic story. So I've pieced together the research, I've pieced together the even clinical insights, and then the herbal wisdom and the nutraceutical responses, and even the genomic and genetic aspects of hormone imbalance, and linked it all together in an algorithm that's assessing urinary clearance for you so that you don't have to remember all of this on your own. You can upload a report into our system and we give you that journey for you. We tell you this is the information that you don't want to miss. These are the areas that the body is screaming are out of balance right now. And we combine it with just very professional, high level, high quality herbal products and nutraceutical blends. And we've been on the market now, I think going on 3 years. We've had so much wonderful feedback, and we're starting to really see the cases return with just significant symptom improvement across the board, be it them cycling women with experiences of PCOS or endometriosis, heavy menstrual periods, PMS, into our peri and postmenopausal years, and even in our male patients. We're getting great response. So it's very exciting, very encouraging. But we have 3 ways that you can engage with our products. If you don't want to get into the urinary hormone aspect yet, totally get it. Remember, symptoms can help guide a little bit as well. And even symptoms with some serum results can give us even more guided insight. And that's why we developed what we call our Axis Matrix. And this is a system that's just asking clinical questions, including a few lab markers to help guide you to some of our products that may be best for your patient at that point in their phase of transition. We do have our hero products as well. This is the Axis line, and these are products that are really great for key areas and phases of a person's life. So, are they a cycling female that just needs well-rounded hormonal support? Formula 4, right? Are they perimenopausal and needing just more guidance or postmenopausal and needing more targeted support? Formula 7. So I can walk you through some of those as well. And then, of course, we have our urinary metabolite differentiation and analysis, which we're calling our axis logic. So some very exciting ways that you can start to utilize and really dive into hormone education. We do have 26 different products. You'll see they're numbered. We numbered them because we're working on the biochemistry. We're not working on symptoms. So it's not like this is a perimenopausal blend. We actually have 3 blends that could be great for women in perimenopause. It just depends on where their dysfunction lies. Do they need more adrenal and mitochondrial support versus do they need more vascular and neurological support versus do they really just need it all? Which is that Formula 7. It just covers all the bases. And again, all of our products really are targeting from production to circulation and receptor response to breakdown and even elimination. So we're really targeting all of these levels. And just to show you how we formulate, right? Again, I talk a lot about estrogen. I have estrogen and progesterone on this slide, so that'll be the E, and then P is progesterone. But when we're thinking about all the responses that hormones have outside of reproduction, skin health. Estrogen helps with collagen. Estrogen and progesterone balance histamine response. Immune regulation, cardiovascular health. We talked about the nitric oxide response. Vaginal health, of course, right? It improves and helps with pH and immune regulation of the vaginal tissue, of endometrial integrity, of the pH of our vaginal canal, of our vaginal fluids. Yeah, mucous membrane integrity, lubrication, the works. That's its primary we always think about. But with mitochondrial health, I like to point out E2 is also a regulator of mitochondrial function. So when estrogens are starting to decline, our mitochondrial health can start to dip. And that's not just for reproduction, that's for the mitochondria throughout all of our bodies. So more fatigue, more brain fog, feeling like you're just pushing through like a sticky, muddy wall, right? Like just this lack of really vitality. Bone support, of course, big one. GI motility. Estrogen helps increase motility. Progesterone actually slows it down a little. We regulate our blood sugars with estrogens, our PEMT, which is our de novo choline response, brain health, immune function. So lots of roles. And so what happens when it all starts to decline? Well, we get dry skin, we get thinning of the skin, we get wrinkles, we get age spots. Our blood pressure starts to go up. We start getting irregular heartbeats. We get more vaginal dryness and atrophy. We get more infections. We have, again, that fatigue and brain fog, osteopenia and joint pains. You can read all of it. I don't need to read the slide to you. But right, like all of these symptoms are related to the fluctuations and ultimate decline of our hormones, but they're made worse if there's underlying inflammation or metabolic imbalance already there. So yes, we can replace a little with our estrogen and progesterone and testosterone even as bioidenticals. But more importantly, our herbs can replace a lot of this function as well. So it's not that it's just the hormones that help activate these various pathways and these different genes. Herbs can do the same, as can cofactors and good nutrients. So for example, BDNF, that acetylcholine response in the brain, bacopa, rhodiola, and curcumin are big activators of BDNF. Our vascular system, protecting our blood vessels and our heart rate and our nitric oxide synthase response with motherwort, with rosemary, vitamin E, alpha-lipoic acid, protecting our mitochondria. I will say nothing protects the bone quite like estrogen, specifically estradiol, but there are some herbs that have had some good success with just bone remineralization. I'm not going to say it's going to replace the effect that estradiol has for the bone, but there are, like, you can still complement, and that's the other beauty of our formulations. It's not to say that it's an either or scenario. It's not like, oh, you can use the herbs or you can use the BHRT. They can complement each other. So you can keep the patients on BHRT and just if they're still symptomatic, right? Like it's just not covering the bases. Instead of chasing the dose, add in the herbs that are going to complement some of those other pathways and improve that metabolic balance for that patient. And this is just a nice article that came. There's so much coming out of our complementary and alternative medicine research groups, but just all the different roles that these herbs play on specifically BDNF, be it through transcription, regulation, or just protein improvement and movement of acetylcholine. And just to also point out that it's not like one herb does one thing, So you're just replacing it with a drug. Herbs have hundreds of constituents. I wanted to point out rhodiola as a key example. Rhodiola increases nitric oxide synthase. It reduces or balances our immune response. It increases neuroplasticity in the brain. It's modulating mitochondrial activity. Like all the different constituents of rhodiola are playing so many roles in the body. So by giving an herb or a blend of different herbs, you're not just doing one thing, you're doing lots of things that are supporting the role that those hormones once played for us as well. So with EndoAxis, you're really getting those three levels of support. You're getting so much support and research at your fingertips. And I want to show you a case if we have time. I know I'm at an hour right now. Is it okay to run through a case with everyone? You think, yeah, good, cool. So let me show you
Sure.
just like in practical.
And Dr. Liz, I did want to tell you, there are many questions that
Okay,
we'll want to go through if we can when you're done with the case study.
absolutely. Yep, I just want to show you how to put EndoAxis into practice with a patient. And so I can do this pretty quickly. But let's say you have a patient, we're going to call her Mary, and she's a 51-year-old female, and she's starting to notice some cycle irregularities, and maybe she's coming to you for something completely different. Maybe she just has some back pain or like a neck ache, and it's like, well, by the way, doc, I also have been struggling with perimenopause, and I'm struggling with what I suspect is perimenopause. I'm getting these cycle irregularities, and I'm like not losing weight anymore, and like I used to, like the things that once worked for me aren't anymore. I'm getting hot flashes, I'm getting night sweats. What's going on? Now, you'll probably be like, oh yeah, it sounds like perimenopause. We have some ideas, but maybe you want a little more information. And you're like, hey, I remember I was on an EndoAxis webinar recently, and they said I can sign up for their platform for free. So I'm going to go sign up and see what they have to say and see if there's any little nuggets that I'm maybe missing. So you can sign up for an account at endoaxis.com. And on our dashboard, you're going to see a few things in your dashboard tab. I want to point you first to education. We also have the Axis Matrix, which are those symptoms, and then you can learn all about the hero products. But if you go into educational resources, you can go into conditions. And specifically, we've outlined lots of conditions that you may be interested in learning more about. But we're going to focus on perimenopause in this case, because you're like, I think this fits like perimenopause. Well, what else should I be thinking about? What else do I need to know? What labs? What treatment options do I have? We go through that all for you at your fingertips. And then maybe you're like, well, maybe I can just pull a product. I don't necessarily need to test her and some of her symptoms, but I don't necessarily need to dive that deep yet. Let's just look at what they have. And you'll see Formula 7 comes up in our hero products. It's postmenopausal support. She's perimenopausal. Is this going to be the ideal? It could. It could be good for her, but maybe we want to think more specific. But we also see that Formula 13 is in the hero products, and this is a calming support. She's noticing anxiety. She notices that she's not having as good a stress resilience as she once did, and her sleep's getting disrupted. Formula 13 seems to fit the bill as I read through it. GABA support, little magnolia in there, some help with mental tension, stress resilience. Yeah, I think I'm going to try 13, right? So right there, you can start to pull some ideas together. But then you're like, well, I do know some symptoms. And I don't know that seven's the perfect blend for her. Let's check in on some quiz scenarios. And in her case, because she is still cycling, you would do the cycling female. So this is for perimenopausal women as well as women under the age of 40 who maybe aren't cycling because of hypothalamic amenorrhea, possibly premature ovarian insufficiency, but we do have that as a caveat within the cycling female flow. So I want to point that out. So in her case, we go through a few questions. And these are actually multi-page questionnaires, and it can be both paper or we do have an electronic version as well. So you can send this directly to your patient, have them fill it out. You'll get the results back. In her case, she was popping up with a lot of low estrogen symptoms, but was higher on the androgen side. So we don't need to push the androgens per se. Maybe we just want to support more her vascular health, her adrenal function, her energy, mood, libido. And that can be done with Formula 8. And again, you'll see some of those herbs that are supporting her brain, her cognition, her vascular health, right? The shatavari, the sage, fenugreek for blood sugar balance, the rhodiola, big one, right? For the BDNF, for also estrogenic support. For energy, it's an adrenal adaptogen by trade. So lots of great herbs in here to target her specific needs. And then, oh yeah, and so I pointed out, like these are the areas that we're now replacing, right? While her estrogens are kind of on a roller coaster, varying 30% day by day. Now maybe we want to go into the detox section as well. See if maybe she could benefit from reducing some oxidative stress. And she comes up positive for Formula 12. This is our Nerve 2 promoter, potent antioxidant. It helps reduce some of the factors that drive 4-hydroxy in particular, but also improves specific enzymes like our GSTs, our methylation pathway, our NQO1, which is NADPH quinone oxoreductase. It's like the little kind of protector of all cell walls that reduces uh, the oxidative damage caused by quinones. And remember, 4-hydroxy forms quinones. That's what damages DNA. So we're going to give her lots of great antioxidants, promoters of NQO1, promoters of methylation, promoters of glutathione, and lots of additional support to her other systems. So now we put together a nice plan. We don't even have to run a test. Again, the questionnaire does ask about a few test markers like testosterone level, SHBG values. If you know her estradiol, if you know her beta glucuronidase, you can add that in and get more targeted information. But even just with symptoms alone, we can start guiding you to some herbal blends that are going to really protect her estrogenic response and give her a nice buffer, protect her brain, protect her vascular tissue, give her a good antioxidant response, and calm her nervous system. And now you're also armed with all that information that you learned, again, for free on the EndoAxis platform, so you can present this to her with confidence. So again, we're not replacing you as a provider, but we're simply giving you the tools to enhance your patient outcomes and help you feel really confident as a provider presenting this information to your patients. So that is EndoAxis. Hopefully that was a good little case review of some of the services and how it looks on that platform. But let me stop the share and I'm happy to dive into some questions. I'm going to take a little sip of tea as well. Just help my voice.
So the first one, and something everyone keeps asking is, will a replay link be sent? A replay link.
Yes,
Okay. So for those
yes,
of you,
absolutely. Yep.
yes, a replace link is being sent out. So I would advise with that too, like gather up your team, right? Or gather up, your patients or your favorites or whatever, and watch it together, and then be able to, you know, answer their questions. It's obviously a lot because Liz is like, mind blowing. So yes, the replay link will be sent out. Then ask about the slides. They'll be in the replay link. We're not just sharing the whole presentation. In terms of here now you can do it yourself. Someone asked, many people don't convert beta carotene to retinol form due to genetics.
True.
So I think that was a statement. I'm not really sure, April, what the question was.
So
Maybe
beta carotene oxygenase, it's the BCMO1 genes. There are variants, and a fair number of patients will have heterozygous, if not homozygous variants of those polymorphisms that render their beta carotene conversion into retinol insufficient, which means they are wholly dependent on retinol from animal sources. This is actually one of the genes I look at often with diet analysis. So for patients that are like, well, I'm a vegan and I want to stay vegan, I'm like, okay, let's look at BCMO1. Let's look at PEMT. That's another one. That's de novo choline synthesis in the liver. If you don't activate that pathway yourself, you need choline from the diet, which means from eggs, from meat sources, from organ meats. So there are a few that really can make being a vegan or vegetarian a lot harder if you're not replacing. But that's why I emphasize, like, if you have a vegan or a vegetarian patient, even if you don't know their genetics, just get them on retinol because that's the form of vitamin A they require that they're not going to get from their diet. That's critical for hormone synthesis and activity. Probably also get them on a good source of choline. And definitely in perimenopause because that PEMT enzyme, that's one of the promoters is estrogen. And when estrogen is no longer available, you're not going to get PEMT. Even if you have perfect genetic function, it's going to be reduced in terms of expression because the estrogen's not there to support it. So,
is
yeah, great
that
point though. And I was going to point that out and I totally jumped over it.
is that one of the formulations then the combination of the retinol and something else you just mentioned? That's one of the formulations we could get through EndoAxis.
Yeah, Formula 7 has the choline and the retinol, vitamin E.
Okay. So is Formula 7 kind of almost, and this is like a gross, a gross, uh, like similarity, but like like your multivitamin is Formula 7?
Not quite,
The
because it doesn't have
hormone.
all like your mineral needs. We
Okay.
actually I put a lot of minerals in our products as cofactor dosing, not as mineral replacement. So,
Okay.
like for example, magnesium and calcium, you may need an additional source. We don't put iron in any of our products because that is so variable, but based on needs of each individual patient. Vitamin D, we don't put in our products because it's so variable based on need and region of the earth you inhabit. So like as a multi, no, it's not going to replace those. But it's really focused. It's a well-rounded, focused product on all the areas that all the really genetic pathways and tissues that lose function when estrogens decline and when progesterone and testosterone decline. So it's targeting those pathways. Mhm.
Okay. Um, so the next question is how is the best way, I think, what is the best way to determine if someone should supplement with pregnenolone?
So pregnenolone supplementation is interesting because pregnenolone is heavily made in the mitochondria. Like that's where it's made. It's made in the mitochondria. And so when you're taking it, is it getting into the cells and can like that conversion and utilization can really depend on what enzymes are upregulated for that patient. So you can't dictate where it goes, right? So that's why I'm always a little cautious with it because if you have a metabolically inflamed patient, you could be pushing pregnenolone into the cortisol pathways, into more of the androgen pathways. Like it could be going into more of a dysfunctional path. Now, the issue or the thing with pregnenolone to remember in urine, you're going to see alpha and beta pregnanediol elevate. Doesn't mean progesterone's elevating. It just breaks down into the same end products. So, is it giving us progesterone or not? Yeah. It is. I think it's great. So, I use pregnenolone when I want to target mitochondrial health. That's really my like cut and dry. Like I'll use it when I'm looking for neurological function, um, like brain fog support, but definitely like mitochondrial support, depression, anxiety. I will sometimes use pregnenolone. But I always
Oh,
make sure that like I'm also supporting inflammation, blood sugar balance, stress. Yeah,
multifaceted. It is not linear, Dr. Liz.
it's not. No, it's not a one for one.
Um, what are your thoughts on the daily urine tests from companies like Mira and Envito?
Yep. So those are what I would. So those are going to be sensitive and not highly sensitive, but those are good screening tests. They're not specific, so they're not a diagnostic test. And I always like to make that delineation. But just like a CGM, like a continuous glucose monitor, they're going to show you trends. So you can see like, oh yeah, like around this time of my cycle, my hormones are trending on the higher end. On this time of the cycle, they're trending lower. And this is likely when I'm ovulating because LH surged. You can see those trends, but for absolutes, like if you're getting a flat line and everything is low, don't trust it. Make sure you're also getting tested because they can underrepresent in some cases. And they're prone to user error too. So I always just like to say they're great. They're great for tracking trends and monitoring symptoms to those trends. Like every time my estrogens go up a little, I get these headaches. Great, that's good information to know. Now let's follow it up with a urine metabolite screen that is a lot more sensitive and specific because of the methodology used. Right? It's not just a little pass through of concentration of a specific hormone in that little sample that you have. That's what Anido and Mira are looking at, or just like little concentrations of peptide elements. Or a little bit like they are looking at progesterone and estradiol as well. Yeah, yes. Um, but in like urinary clearance on like a Dutch test, you're seeing they're evaluating those hormones via extraction and then LCM SMS. So a lot more refined way to see the like actual peaks and amount of hormone in a specific way within that sample. Does that make sense? Like
Yeah.
tracking trends versus tracking absolutes. I would say. Yeah.
And can you just kind of talk uh in a wide net of the difference between screening and diagnostic because we see, like there's a difference between a screening mammogram and a diagnostic mammogram, a screening colonoscopy and a diagnostic. So as it relates to hormones, to make sure that, anyone who's just entering this field or maybe in it, they're aware like what is a screening and what is a diagnostic testing.
So at its like core, a screening test is one that has good sensitivity, meaning that if it's so, do you know about sensitivity and specificity when it relates to a lab test? Like
No, let's
sensitivity
talk about it.
means, yeah, so sensitivity means, so I was always taught spin and snout. So a specific test, specificity, if the test is positive, you can rule it in. A sensitive test, sensitivity, if it's negative, you can rule it out. So when it comes to a sensitivity of a test, sensitive tests are tests that, oh, sorry, just a pop-up question. So sensitive tests are tests that you can say like would be like a flu B test. Like if you're doing like, oh, I think I'm sick, I'm going to do a nasal swab and oh, it's negative. Great, you likely don't have flu. Right? Like it's a test to say, great, you don't have this issue. You don't have a problem. So that can be a good screen because you're going to catch the true positives a lot more clearly. So if there is something really out of balance, yeah, it probably is. Whereas a specific test, you can capture the true negatives. That is what you want when you're looking at a diagnostic test, is good sensitivity and specificity to say, hey, if this is high, it truly is high. If this is low, it truly is low. And this is what we can do with it. Versus like a sensitive test is like, well, yeah, if nothing's wrong, probably nothing is wrong. But if something does look off, you probably want to get that validated and confirmed. So that's
So
kind of
does,
the difference.
does screening necessarily rule out and rule in, and diagnostic gives it a name?
Exactly.
Is that about
Specifically when performed correctly, right? That's the other element is
it?
don't, you want to test it at the right time of the cycle, at the right time of
Yeah,
day to get the answer you're looking for. Yeah.
so
Um,
important.
yeah.
So important.
And the type of methodology is important because when you're looking at really, really small fractions of hormone, I a lot of serum tests and a lot of salivary tests use immunoassay because it's cheap. It's cheap to run, it's quick to run. When you're looking at really, really small fractions of hormone, immunoassay will not cut it. So it's not ideal for postmenopausal estradiol. It's not ideal for estradiol in men. It's not ideal for testosterone in women because there's such a small fraction of those hormones around that you're not going to get accuracy in the output. Versus like LCMS is very sensitive and specific. You're really going to see that refined. You can capture those really small amounts much more clearly. So,
Which would be
like,
the
this would
Dutch
be like
test.
ultra sensitive.
Which would be the Dutch test.
The Dutch test uses LCMS for urine. In serum, you have to specifically ask for ultra sensitive estradiol or for LCMS for your total testosterone. Yeah.
So if you don't want to have to remember those things, whether you're a clinician or a patient, opt for the Dutch test as it relates to your hormones. Is that accurate or not?
Different, but it's different views, right? So you're seeing different things. I will say urine is notoriously poor at capturing androgens correctly because there's so many variables to how testosterone can eliminate into urine specifically. So getting serum is really important for testosterone to confirm what you're seeing. But again, it has to be that morning draw, and you really do want the LCMS total testosterone in tandem with SHBG values.
Okay.
Free testosterone is notoriously poor in serum. So calculate. They actually researchers have shown that calculating free testosterone is more accurate. And based on, in research settings, they can really extract and evaluate free testosterone very clearly, but this is a very labor intensive process that a conventional lab would not be able to incorporate. And so when they're comparing their labor intensive process and free testosterone to the free testosterone that's conventionally run in a lot of labs, not accurate at all. What is more accurate is taking what's called the Vermeulen calculation and looking at binding efficiency quotients of SHBG and albumin as it relates to testosterone taking your total testosterone, albumin, and SHBG levels and calculating out your free testosterone using that calculator. So just an aside.
Is anyone else feeling like maybe efficiency and even, time efficiency and financial efficiency really can hurt us, right? Like if we're just going for whatever's cheap and whatever's fast, we may get really skewed results. Okay, the next question is, can Dutch be accurate for menopausal women using BHR in parentheses estradiol patch?
Yes. In fact, they have white papers showing efficacy as it relates to serum values, as well as efficacy with the metabolite clearance in terms of how the body is utilizing that hormone, its bioavailable levels. It's very accurate.
Okay. And then the next question, how do you answer to objection EndoAxis products have many ingredients in each one, and when taken by clients who have some side effects, it's hard to navigate them because we don't know how much one is the main culprit causing the issue.
So a few things on that. We do. We have very robust blends. This is true. We get really great results because of it, but for sensitive patients, absolutely, it can be a problem. So number one, if you know you have a sensitive patient, well, okay, first, I want to preface that our ingredients and our levels of each nutrient and herb are at mid-level therapeutic dosing. Meaning in the research, there is a range that says, for these targeted conditions or these targeted pathways, you want somewhere between this amount and this amount, of this nutrient or of this herb. And so we kind of cut the difference and give you about mid-range, depending on the herb. If it's a really potent herb, we'll reduce it a little bit because it's in concert with so many other elements. If you have a sensitive patient, bottle dosing may be too strong for them. So with my sensitive patients, number one, only start with one product at a time. Generally start with the adrenals. So I always start with one of our adrenal products first because that can, in many ways, because our adrenal blends are targeting mitochondrial dysfunction, inflammation, blood sugar balance, and in some ways, like indirectly hormone health, that can be a great starting place for everyone anyway. But it tends to be the more tolerated blends with some caveats and start low dose. Start with just half the bottle dosing. So if the bottle dose is 2 caps twice a day, start with just 2 caps once a day, or even 1 cap once a day, and see how they do. That could be enough for them. If you're like, no, I think the hot flashes really are their most symptomatic. They don't have a lot of adrenal. They're not really chronically stressed. Their sleep's great. Like I don't want to treat that pathway. Then do the hormonal blend, which would be the Harmony product, and again, just half the dose. You don't have to do all the products all at once. We do list them as options, but again, we're that's what we are. We're a tool to give you options. We're not a tool to say this is what you have to do. And so you do need to still understand, your patient best, So understand your patient, their needs, where you want to start. If you want to start with detox, but just start with one product, half the dose, and see how they feel. And then you can add an additional product if they want that support.
Mm.
But you may be like, I think we're going to bring in BHRT anyway. Let's just start with reducing oxidative burden and treat the adrenals and just start on half the dose. That's absolutely appropriate. Yeah.
And what time frame, Dr. Liz, do you recommend in these testing? Like if I started with I don't know, the adrenal support today, and we're just testing to see how it's working. Is that a 30-day? Is that a 60-day? Is that a 90-day? What do you?
Most cells turn over on a 3-month axis. Like some have faster turnover, some have a little longer, but on average, it's about a 3-month turnaround to see change at a cellular level. So I usually say if it takes 3 months to see the change, and who knows how variable they are with the product right up front, I'm usually saying 4 to 6 months for a retest, but
Okay.
monitoring symptoms along the way.
Okay. So that's important to know,
Yes.
right? Like I think any time we're impacting and the goal is to impact at the cellular level, it's not going to be a pharmaceutical that is designed to, you know, I don't want to say mask the symptoms, but a lot of times that's what it is just to change that. Like changing the symptoms versus healing the cell is a totally different journey. So I would just encourage all of you, make sure you're having that conversation, right? It looks better for us as providers, and it also helps the patient see like this is a journey that like, is this what you're wanting to do? Are you wanting the journey of well-being versus just the suppression of symptoms? Because those are totally different worlds. And it bears witness to have that conversation. um so the next question: how do we get the electronic version of your assessment? I only saw the PDF.
So you'll need to upload or make a new patient. When you make a new patient, it's going to say upload a report, or it's going to give you two options if it's a brand new patient. So you'll enter in their information. You don't have to enter in if you don't want to give like their exact name and exact date of birth, that's okay. You don't need to add that, but you can, we need their year, their birth year to be correct. And then it'll take you to a page to either upload a Dutch or add a test. And that's the link you'll send. And then you'll choose which test you want to send them. It'll send to the email that you put in their patient report. They'll receive it. If you want it to come to you, put your name, your email, and it'll send to you. Um, and then you can answer the questions and it'll return results to your email as well as on your dashboard.
So if I hear you right, if I'm a provider and I want to manage the patient, then I may have 30 different EndoAxis profiles, and then I get the report and then I give it to the patient instead of, so basically using the EndoAxis platform as a tool for me and my patient without
Yes, so the
the.
patient won't have access to your platform and they won't have access to anything you don't recommend to them, right? Like they go fully through you, but you're their gatekeeper and it's all accessed on your dashboard. Do you want me to walk through it on the website or, I mean, would that help or I don't know?
um I think that would be a great thing. I just have to say I have to jump off. Um,
Totally.
and there's one more question, if you can address it after showing this at 11:20 when you look in the chart on the
Why
chat.
don't we answer that question really quickly and then I'll pop over to
Okay.
a test.
And so that is wanting clarification. So pregnenolone metabolites, like in a Dutch, won't really tell you if enough pregnenolone is produced or circulating. So what is the recommended lab testing again?
Oh, for pregnenolone testing, there's really not a good way to test pregnenolone. I won't lie. Like what you're seeing in a serum test will give you circulating levels, but if it's circulating, it's not in a closed system, and it should be in a closed system. So I'm always a little wary about what pregnenolone tells us in circulation, but it should, like, that would be the way that you can assess. Like, if it's low, then yeah, and like, doesn't mean it's not low in the cell, but there might be an issue. If it's really high, I usually think more about like mitochondrial emergency or stress, like leaching the pregnenolone, but or supplementation. Um, but that's just my own little clinical observation on that one. But yeah, yeah,
And
it's
then
tricky. It's
April
mhm.
Morgan, you said my questions are under Q&A. Um, Ellie, you'll have to, I don't see that on my side, so you'll have to find those and address those, please. And then if Dr. Liz, you can I think now do the so here's where it is. If you Dr. Liz click on the bottom of your Zoom screen, all the way to the right, it says more. And if you click
Gotcha.
on
Yep.
that, then there's a Q&A. So thank you
Perfect.
all. This has been so amazing. Make sure that you take the time to watch the replay. So Allie and Dr. Liz, thank you so much. This is super awesome.
Absolutely. Thank you. This was so fun. And again, I'm sorry for sometimes I get so excited, I just go too fast. My brain has to catch up. So hopefully it was good information and
You have a lot, and we are just learning. So it takes repetition, right? That's how we myelinate. It doesn't happen one time. So now Dr. Liz is going to show you all the interface that you'll see so that we don't have to have any questions or confusion.
absolutely. I'm
Thank
honored to
you.
take you on a walkthrough. And thank you so much, Dr. Eaton. This was such a pleasure. Thank
Yeah.
you. Excellent. All right. So let me share my screen really quickly and thanks for all. I know this is going long, so thanks for hanging out there. And of course, we'll send this link out as well. So this would be my provider. This is my demo dashboard. When I add a patient, it's a little slow every time I do this, but I'm just going to do demo quiz patient. Um, So you would put the email that you're looking for your patient, or again, you can put your direct email as well if you wanted to send over to you to answer all the questions. But that just makes it easier for the patient to be able to receive it. We historically were calling the Axis matrix the PECM, which we were calling the phytoendocrine clinical matrix. That was a mouthful, so we changed it to Axis matrix, shortened it, but you'll see the send PECM. This will be updated graphically here in just a few days as well. But this is where you can see those quizzes. And you would just click on the send to patient. Now, the other thing you can do once that's sent, so I have demo quiz, I can go to my patients, go down to my demo quiz, and I can also copy the link for it. So if they have not sent the results yet, I can copy this link and also just put it into a tab if I want to see those questions. So that's another way you can get to those questions electronically. But mostly it's going to be through, if you already have an established patient, you'll just go into the patient and upload the labs that way. And it'll take you to that same page, send PECM. And then once you get the results, you'll see the results. This gal has answered. You'll see all the questions that they answered. So this one said they had a score of 4. If you're curious what they said, you can expand it and see what they answered. And then they were recommended Formula 11, and you can send it over to Shopify if you would like, or we are also on FullScript. So that is how you can utilize that aspect of our system. And then I did want to show you, I promised the Human Protein Atlas for CYP1B1. Again, look at this. Like, it is expressed in almost every single tissue in the body, hardly at all in the liver. So when we think about estrogen detox as being predominantly in the liver, it's not. It's like any cell that estrogen can pass through can become 4-hydroxy or 2-hydroxy. And I'll show you CYP1A1. Also expressed in so many other cells, a little more in the liver, but so many other cells in the body that it can pass through. So just to bring that awareness, and I think, we get so myopic when we think about estrogen clearance and thinking about detox in general as being chiefly liver based, and it's not. The liver does a lot of heavy lifting for sure, but it's not the end all. And then this is the 3A4, just to reiterate. 3A4 is like in every, or very, very densely in just the liver and the gut. So that's the powerhouse player in the liver. And that's CYP 3A4, which would convert estrogens into 16-hydroxy-E1 and 16-hydroxy-E2, which is often called estriol. All right, so then I have a few more questions here in the chat section. So I'll go in reverse order. So yes, you can calculate free testosterone, and you use the Vermeulen calculation. I'm going to type it here so that you can put it to mouthful. And this is a free calculator that you can get online. Vermeulen calculator. That's there. Yeah. So that should have sent out. We'll send this also in an end of email wrap up, but it's the Vermeulen, Veruleum, Vermeulen calculator for free testosterone. And that just takes the total testosterone, sex hormone binding globulin, and albumin and calculates out your free testosterone. We actually use this same calculator in our system when you're uploading a Dutch test. If you have their serum testosterone and sex hormone binding globulin, you can enter them and we'll calculate it out for you as well. And then does 16, Vermeulen, V as in Victor, Ermuleun, Vermeulen. Yep, absolutely. You're welcome. And then does 16-OH go up primarily due to beta-glucuronidase producers? So 16-OH is going to drive up if CYP3A4 is upregulated as well. So anything that's driving CYP3A4 expression in the liver, which can include cortisol, both our own produced or glucocorticoid medications, as well as other medications. 3A4 is a powerhouse pathway. It metabolizes around 60% of medications and toxin exposures that we need to process through the liver. So it's doing a lot of heavy lifting. But if it's upregulated in transcription, I kind of think it like a movie theater line. If estrogen's passing through the liver and that movie theater line is moving fast, it's going to be like, oh, okay, let's go this way now, right? It's going to move into that 16-hydroxy a little more readily. The issue with 16-hydroxy E1 is that it does bind to estrogen receptor alpha receptors. So it can cause proliferation. So you're getting like a double whammy of estrogen on those receptors. Whereas 4-hydroxy doesn't actually bind to the receptors as much. It's more that it converts to 3,4-estrone quinones that damage the DNA. But in the gut, it's specific to beta glucuronidase. If you have inflammation in the gut, so like if you had like yeast issues, candida, poor bile acids, that can also cause an issue with that or the conjugation of those 16-hydroxy metabolites, because that's the other aspect of clearance. It's not methylated, it's conjugated with sulfation groups and bile salts. So it's going to need taurine, it's going to need MSM, it's going to need, well, really taurine and choline are your two big ones, and N-acetylcysteine. So again, is it an issue with too much promotion? Is it an issue with recirculation? And any inflammation in the gut can be a contributor to that, but it's heavily dependent on the beta glucuronidase response in particular. And then, or is it an issue with actual conjugation and pulling it out through that sulfation pathway? So yes, inflammation, bile acid, poor bile acid pool, reduced digestive function would all create an issue with 16-hydroxy. Lots of factors, but all indirect. Yeah. And then with a serum E2, so you have E2 at a 92, but FSH is still around 74, which is on the high end for sure. How can you decrease FSH? Because it does have that contribution to higher bone turnover. That's a great question. Number one, again, the serum is a single point in time, so it would be more tracking the value over time. You could do a urinary analysis to see that daily average of tissue response, or do multiple collection points, not on the same day, but like maybe do a couple throughout the week if they're game. But really like seeing what is their trend and knowing that if FSH is not responding, they don't have enough consistent estrogen at a good level. They're likely dipping too much. So that 92 could be bolus level after applying estrogen and then going in and getting tested. You're reaching their peak, but you don't know their trough. So you can also test, like if they apply in the evening, test like midday and see, you know, a few hours before their next application, where's their lowest level? That will tell you where they bottom out because they may be too low, if that makes sense, right? Like, so kind of just teasing out like, where is their lowest? Because you're just seeing a single point, and that doesn't mean that that's their point all the time because they're only applying. Well, it depends on what they're using too. I'm assuming it's a cream in my head right now. So if they're only applying once a day, they might need twice a day dosing. If they're applying, but it's not lasting and giving them stability all day long, again, like the FSH is telling us they're not getting the right feedback response to the brain to say we have enough estrogen in circulation. So somewhere along the way, their estrogens are too low. Also, insulin resistance, metabolic syndrome, liver issues can all impact FSH response, and would impact estrogen's response as well to the receptors. So making sure that their blood sugars are balanced, making sure that their skeletal muscle is, performing well, that they're metabolizing glucose appropriately. Like there's so many, I could go into a whole spiral, but support their liver, support glucose, support stress, and then see what their trough is and see if they maybe need a boost in their dose. And that came from April Morgan. I don't know if she's still on, but April, did that answer your question? I don't know if she's on still. Yeah, we'll send those as well. Oh, yeah. Oh, perfect. Excellent. Good. Wonderful. Yeah, so thank you so much. I know this is like going on 2-hour talk, so I don't want to keep you guys any longer. Are there any further questions? I think I got to everything. Answered those. You're so very welcome. Yes, thank you all for hanging in there with me. And again, we will definitely give you the link to the live recording so you can revisit. I know I put in little nuggets there that weren't necessarily reflected in the slides, so good to re-listen and pick up those little tidbits. And again, have a wonderful afternoon. Thank you so much for joining and hope to see you again on a webinar in the future. Take care.